In section 7 of chapter 10, our last section in the chapter, we're going to be proving angles congruent. So look at the gray box at the bottom of page 636. It says, you can prove that this relationship is always true by using deductive reasoning. So the relationship they're talking about is vertical angles. Now you've done that before. Here's a vocab word. We are starting with theorems. That section in the back of your book, Z1, we're starting with those, theorems. A theorem is a conjecture or statement that you prove true. So your essential understanding says this: you can use given information, definitions, properties, postulates, and previously proven theorems as reasons in a proof. So here's your very first theorem. Vertical angles are congruent. As you can see with the diagram, angles 1 and 3 and angles 2 and 4 are vertical. Vertical angles that are vertical angles are angles that are crossing each other, but they're formed by two intersecting lines, and they would be the angles that are crossing each other. So, in your gray region, when you are writing a geometric proof, it may help to separate the theorem you want to prove into a hypothesis and conclusion. Another way to write vertical angle theorem is, if two angles are vertical, then they are congruent. The hypothesis becomes the given statement, and the conclusion becomes what you want to prove. A two-column proof of vertical angles theorem follows. So it shows you in the next page how vertical angles have been proven. Now, all this is proving that vertical angles are congruent. And what it's given, as you can see, it's given that angles 1 and 3 are vertical angles, and therefore then angles 1 and angle 3 are congruent. So it's an if-then statement. It is, if two angles are vertical, then they are congruent. That proof just shows that. So because it shows it, you can now use that theorem in a proof. On problem 1 on page 637, under the got it, we want to find the value of x. I have copied it here into this problem. This is not a proof. We just have to find the value of x. So because vertical angles are congruent, we can write the equation 3x equals 2x plus 40. We subtract 2x on both sides, and therefore the value of x is 40. In practice 1, we want to find the value of each variable. Now we have a couple of ways to do this. We can start with the y if you want to, or we can start with the 2x. So because 2x and 76 are vertical, we're going to write 2x equals 76. Divide both sides by 2. That gives us the value of x is 38. Now, we could also say that y and 76, they're supplementary. They make a straight line. So we know they add up to 180, so if you really wanted to, you can write an equation, or you can just take 180 minus 76. And 180 minus 76 gives you 104. So the value of x is 38, the value of y is 104. Problem 1, very easy. Problem 2, we're now going to use a proof by using the vertical angles theorem. So we are going to now go to a proof. So I have copied down the got it problem where it says given. Angle 1 is congruent to angle 2. So what I always do is I always mark the givens. So we know those two angles are congruent. We have to prove that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. We basically have to prove that all four angles are equal. So let's start our proof. Our given, angle 1 is congruent to angle 2, and our reason is because it's the given. Step 2. We can prove that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Why? Because you can just say vertical angles are congruent. You could also say vertical angles theorem, but I would like you just to start using that vertical angles are congruent. That's what you know. vertical angles are congruent. So, we have now proven that angle 1 and angle 3 and angle 2 and angle 4 are congruent to each other. Now, one thing I want to make note here. Did you notice that we're not going like I can't talk. You'll notice in the given that we have congruency. In the problems we did on Thursday, we went to the measures of the angles are equal. We changed this to equal. The reason we're not doing that is because both our given and our proof have to do with congruency. So we don't have to do anything with things being equal here. So, let's keep going. We then can say that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. And here's why. Our statement, our given, was angle 1 is congruent to angle 2. We then know angle 2 is congruent to angle 4. Because 1 and 2 are congruent, and 2 and 4 are congruent, then we can say 1 is congruent to 4. We also know that angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, therefore angle 2 is congruent to angle 3. We have not used this yet, but this is transitive property of, now we're talking about congruency, not equality here, so transitive property of congruency. So we have just proven, look at this, look at what we've just proven. We have to prove that all of the angles are congruent. We know 1 is congruent to 3, we know 1 is congruent to 2, we know 1 is congruent to 4, we know 2 is congruent to 4, we know 2 is congruent to 3. Therefore, we have just proven that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. And it's actually the exact same thing. The reason is because we can put them all together. It's because of the transitive property of congruency. Now, on page 639, in the middle of the page, it has another vocab word, a paragraph proof. A paragraph proof is basically taking a proof that you would write in a T-table type format, and you write it in sentences as a paragraph. We are not to that point yet. I do not feel comfortable giving you guys paragraph proofs yet. I like the statement, reason, T-table proofs. So don't worry right now about doing paragraph proofs. At the bottom of page 639, here's your second theorem. The theorem says this: if two angles are supplements of the same angle, or of congruent angles, then the two angles are congruent. For example, look at the picture. You have three angles. If angle 1 is supplementary to 3, and angle 2 is supplementary to 3, so both 1 and 2 are each supplementary to 3, then we know that angle 1 and angle 2 are congruent. So I'm going to say this one more time. Angle 1 and angle 3 are supplements. Angle 2 and angle 3 are supplements. Therefore, angle 1 and angle 2 are congruent. This is the congruent supplements theorem. On the top of page 641, you have three more theorems. So let's look at theorem 3. Congruent complements theorem. It's the same type of thing as supplementary angles, except now it deals with complementary angles. Here's what it says. If two angles are complements of the same angle, then the two angles are congruent. So, if angle 1 is complementary to angle 2, and angle 3 is complementary to angle 2, then angle 1 and angle 3 are congruent. Theorem 4 is easy. All right angles are congruent. So, for example, if angle 1 is a right angle and angle 2 is a right angle, then angle 1 is congruent to angle 2. Theorem 5. If two angles are congruent and supplementary, then each is a right angle. So, for example, if angle 1 is congruent to angle 2, and angle 1 and 2 are supplementary, which means they add to 180, then the measure of angle 1 equals the measure of angle 2, which means they both equal 90. And it notes there that you will prove Theorem 5 in exercise 19. And if you look above in Theorem 4, it says you will prove Theorem 4 in exercise 14.